Isaac Newton, a true giant of science. You know the apple story, but Newton was more than a legend. He questioned everything. Why does the apple fall? Why do planets move? And crucially, what is light? Before Newton, people thought white light was pure, and colors were just stains. Newton challenged this. He wanted proof, not just old ideas. With simple tools, he set out to test the nature of light. Newton showed that sunlight held a hidden rainbow, a reality no one had seen before. His curiosity changed how we see the world. Let's see how he did it. Newton needed control, so he turned his room into a laboratory. He blocked out all light, making it pitch black. Then he made a single tiny hole in the shutter, just enough for a sharp beam of sunlight. This isolated ray was his subject, cutting through the darkness like a spotlight. The dark room was essential. Any color he saw had to come from the sunlight itself, not reflections or stray light. With this setup, Newton could study light with precision. It was a simple but brilliant way to isolate the phenomenon. In the 17th century, this was cutting-edge experimental design. Now, with his controlled beam, Newton was ready for the next step. He would introduce a prism and ask, what happens when pure sunlight meets glass? The answer would change science forever. Newton placed a prism in the path of his sunbeam. On the wall, the white spot vanished, replaced by a vivid band of colors: red, orange, yellow, green, blue, violet. This was the spectrum, a rainbow created from sunlight. Newton noticed the order never changed. Red, bent the least, violet the most. The prism wasn't adding color, it was separating something already there. Newton realized white light was a mixture of all these colors. The prism simply split them apart, each color bending differently. Could a single color be split further, or was it pure? Newton was about to find out. To silence doubters, Newton designed the experimentum crucis, the critical experiment. He split sunlight with a prism, creating a spectrum on a screen with a slit. He let only one color, say red, pass through the slit. Then he directed this pure color through a second prism. If the prism created colors, the red should split or change. But it didn't. The red stayed red, just bent. He repeated this with blue, green, and every color. Each remained unchanged. The second prism couldn't break down a single color any further. This proved the colors were fundamental, not created by the glass. White light was a blend, the spectrum's colors were its ingredients. Newton's experiment left no doubt. He had revealed the true nature of light. The scientific world would never see light the same way again. Newton's method became the foundation of modern optics, but the story of light was far from over. Newton's focus was on what he could see. He mapped the visible spectrum, showing white light was a mix of rainbow colors, but he never thought to measure the temperature of each color. The idea of invisible light or heat beyond the rainbow wasn't on anyone's mind. For Newton, the spectrum ended at red and violet, nothing more. He gave us the tools and framework to study light, but the invisible remained hidden. Science builds layer by layer, and Newton's work set the stage for new questions. The next breakthrough would come from someone willing to look beyond what the eye could see. Jump ahead to 1800. Enter William Herschel, astronomer and inventor. Herschel, curious about sunlight and heat, was testing colored filters for his telescopes. He noticed some filters blocked light but let heat through, sparking a new question. Do different colors carry different amounts of heat? To find out, Herschel recreated Newton's prism experiment but added thermometers. He split sunlight into a spectrum and placed thermometers in each color band: violet, blue, green, yellow, red. Herschel was building directly on Newton's work but asking a new question. He wanted to know, How does heat vary across the spectrum? This was a fresh approach, combining old methods with new curiosity. Without Newton's prism, Herschel's experiment wouldn't have been possible. He was about to discover something Newton never imagined. The invisible was about to be revealed. Herschel measured the temperature in each color of the spectrum. He found the temperature rose from violet to red. Red was the warmest. But then he placed a thermometer just beyond the red, in the darkness. To his shock, it showed the highest temperature of all. There was invisible energy, what he called calorific rays, beyond red. Today, we know this as infrared radiation. Infra meaning below red. Herschel had discovered a form of light our eyes can't see, but we can feel as heat. The spectrum was bigger than Newton imagined, stretching into the invisible. This discovery opened the door to the full electromagnetic spectrum. If there was light beyond red, what about beyond violet? Spoiler, ultraviolet was next. Herschel's curiosity, built on Newton's method, revealed a hidden universe. The visible rainbow was just the beginning. Science had found a new frontier. Herschel's discovery of infrared changed the world. Today we use infrared light everywhere, like in your TV remote. Infrared is heat radiation. All warm objects emit it. Night vision goggles and thermal cameras detect infrared, letting us see in the dark. Firefighters, police, and doctors use it to find people or diagnose illness. Infrared cameras spot heat leaks in buildings, making homes more efficient. Astronomers use infrared telescopes to peer through cosmic dust and see hidden stars. From weather satellites to automatic doors, infrared is everywhere. All this came from a simple experiment with a prism and a thermometer. Curiosity about invisible light led to technology that shapes our lives. From Newton's dark room to the James Webb Space Telescope, the journey of light is a story of curiosity and discovery. Newton's prism showed us the rainbow inside sunlight and taught us to question everything. Herschel, building on Newton's work, found invisible light, infrared, expanding our view of the universe. Their experiments led to the discovery of the full electromagnetic spectrum, from radio waves to gamma rays. Our modern world, wireless tech, medical imaging, astronomy, rests on these breakthroughs. Newton's real legacy is the scientific method. Question, test, and never stop exploring. Every discovery is a step for the next scientist to climb higher. That single beam of light in a dark room still illuminates our path. The universe hides wonders in plain sight if you dare to ask new questions. Science is the courage to look deeper, and the universe is always ready to answer.